Alright, here is the second page. It says determine the appropriate viewing rectangle, blah blah blah. So I have taken the liberty to put this onto the calculator, and there it is. It's partly an exercise in just typing in things very carefully. 100 minus x squared raised to the 0.5 power, that's really the square root. Okay? So you need to ask yourself, what types of values are you going to be able to have? Well, you cannot take the square root of a negative. So 100 cannot be, you cannot take away from 100 a number larger than 100, otherwise you'll get a negative. So it can't be 100 minus 200, say, whatever. So those x's have to be smaller than the square root of 100, which is 10. So I know that my viewing rectangle, guess what, is going to be very close to the standard viewing rectangle. So I'm giving you a softball here on the test. Be prepared to use your smarts. If that was not 100 but was 10,000, then you'd have a much larger number. If it was 9, you'd be plus or minus like 3. All right? But if I go to the window and change this to, say, negative 11 and then positive 11, and my scale maybe every 2. Once I've bracketed the x's, I simply need to do zoom 0. And I'm going to get a graph that hopefully looks somewhat sensible. It should have that in there. That's good. If you want to be fancy, you can do zoom 5 after this, and this will make the x's and the y's, x and y axes at the same scale. Alright, and it turns out it's half of a circle. Alright, so I'm going to sketch that quickly now so I don't waste your time watching, but it'll be something like that. And it does actually come down and touch these. That's just a round off error in your calculator, and this is going to be minus 10, and this is going to be plus 10, and this is going to be 0, 10, and that's good. Or you can sketch just a label in your window, either one, to give your drawing some scale there. Alright, next is the show each step while solving for the given variable. Here, I'd love you to do this without aid of a calculator. Just notice that this is base 6. Each of these are base 6, so I can write this log base 6 of the product of these two. When you multiply those two together, 3 times 12, you get 36. So log base 6 of 36, well, that's equal to the log base 6 of 6 squared. The 2 comes out front, and the log base 6 of 6 cancels, and you just get 2. Okay? This one is more calculator oriented. You're going to just peel away the layers to get at the x. You've got to start from the outside and go in, so I'm going to take away 3. I get 120. I'm going to divide by 6 on both sides, and I'm going to get 20 then. So I get 7 raised to the x minus 2 equals 20. Well, then I take the log of both sides. Again, I have a preference for ln. Doesn't matter. You can take the base 10 log of both sides. When I do that, this x minus 2 comes out front. Alright? So I get x minus 2 out in front times the ln of 7. That's going to be equal to the ln of 20. And after that, it's pretty simple algebra. I divide both sides by ln of 7, and that will cancel. And then I add 2. So x then is equal to the ln of 20 over the ln of 7 plus 2. Put that into your calculator and see what you get. And I've got ln 20 divided by ln 7, and then I'm going to add 2. And I get approximately, wavy equal sign there because it is not going to be exact, 3.54 I'll write. Alright? And you can plug that and check. Subtract 2, take 7 and raise it to that. Nice thing about these types of problems is you can always check your answers. Okay, back to one that was similar to the quiz. You know that 10 is greater than A. A is less than 10, but A is greater than E. So somewhere between about 2.7 and 10. Sketch an approximate graph of each of these. Well, let's see. If I put my major axes, say, right there, okay, and right down the middle here for y, a to the x is going to be something bigger than 2.7. Just say it's 3. Make it a convenient number. It's going to go like this, and then it's going to go something up like that. It's quite steep still, okay? And you can label this a to the x. A to the x minus 2, then whatever you do there, this is going to shift it 2 units to the right. So I need to label 2 points. So I'm going to label this 0, comma 1, and then this is 1, comma a, because when x is 1, it's going to be a to the 1 is a. This point, then all these points get shifted 3 units and 3 units, and so it's going to come along like this and zoom up, but just be 3 units. So this is a to the x. Oops, I said 3, but I meant 2. There's a little typo. You just got to imagine these go back. I'm going to label it. That's the important thing, is how you label it. So this is 2, comma 1, and then this is 3, comma 1 plus a. That's the second one. Then this final one, the ratio of e. E is less than a. So e is less than a, so it's going to be less than 1. Exponential of something that is less than 1 is going to come from above and go down like that. And then it's being flipped over the y-axis. So you need simply to draw something that comes from below and goes like that. It's all about the flip. And just label it carefully. Minus e over a, whole thing, whoops, minus sign out front, that's pretty important. That to the x, okay? There we go, all done.